This video is on example 3. We're going to simplify the following expressions. We've actually got 12 of them, so we're going to go through them pretty quickly. If you need to pause, please do and go back. In the first expression, I'm seeing that we have two terms on the inside of a set of parentheses. We have a term on the outside that we need to multiply by each term on the inside. So we need to multiply negative 2 and x and negative 2 and 3. Negative 2 times x is just negative 2x. Negative 2 times positive 3, that's going to be negative 6. Turns out that these are not like terms. We'd have to have an x here, or we'd have to have this x gone. Then those would just be constants and we can add those together. But we can't add these together because they're not like terms. So this is the best we can do when we simplify that expression. In number 2, we need to use the distributive property first. You'll notice that there are two terms here on the inside. There's an x and a negative 3. And then we'll subtract 6x later. The negative 3 does not need to be distributed to the negative 6x because it's not in parentheses. Whoever wrote this expression, if they wanted you to distribute the negative 3 all the way across to the negative 6x, they just have to take this parenthesis and move it out over here. But that's not the case, so we're not going to do that. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And we still have a negative 6x that we didn't touch. When you have just a bunch of terms here, no sets of parentheses or anything of that sort, it's time to see if we can combine like terms. I'm looking at this negative 3 right now and this negative 6. Each one of these terms has an x in it. Those are the coefficients. So we can combine those. We don't want to combine these with the 9 though. The 9 is just a constant, doesn't have a variable there. So negative 3 minus 6 is negative 9x. There's an x there. And then plus 9. We can't simplify this any further. Negative 9x and 9 are not like terms, so we're good to go. In this example on 3 here, we do have to do some distribution. You'll notice that there are two terms on the inside of this set of parentheses. So we're going to need to multiply this negative 2x by the first term and also the second term. Then we'll add 6 later. Negative 2x times x is negative 2x squared. X times x is x squared. Negative 2x times positive 2, that's a negative times a positive, so that's going to be negative. 2 times 2 is 4, and of course there's an x there. Then we'll need to add 6. If we look at each one of these three terms, neither one is like any of the others. So we can't really do anything to simplify it. It just is the way it is, and that's okay. As we move on, I'm noticing that there are two terms here in the inside of these parentheses. So we'll use the distributive property to see if we can help find a solution for this one. Negative times a positive is a negative. Negative x times 2x. We usually write the number part first, or the coefficient is what I mean to say. So that's going to be 2, and then x times x is x squared. Negative x times negative 7 is positive 7x, and then there's a plus 4x here on the side as well. We can combine these two terms. They're like terms, but we can't combine them with this negative 2x squared. 7 plus 4 is 11, and we're talking about x's, so it'll be 11x. Notice how this term has an x squared, this term has an x, and we can't add those together. They aren't like terms. This next example, we need to multiply 5 times negative 9, and then there's also an x there. So that's negative 45x minus 3x plus 2x. All of these are like terms, so we could take negative 45, subtract 3, and then add 2, and of course there will be an x there. So I'll write that down just to remind myself. Negative 45 minus 3 is negative 48, plus 2 is negative 46. You could also do negative 3 plus 2, and that's negative 1. And then do negative 45 minus 1, which is negative 46x. In example 6, there's no distribution to do, so we can just combine these. Negative 4x minus 5x, that's negative 9x. Yeah, that one wasn't too bad. We'll move on with the same things from example 3. We've got 6 more to knock out here. So we've got, actually I lied, I think we have a 13 and a 14, so we've got 8 more. I just saw that sheet over here on the side. Oh, you guys are in luck. So in this example, we need to do 2 times 3x, which is 6x, 2 times 1, which is 2, and then we need to add x. 6x and x, that's 7x, and then plus 2. To use the distributive property here in this next one, it's going to be negative 2x, negative 2 times negative 3 is positive 6, and then 5. You'll notice how we have 2 terms here that are like terms. They are 6 and 5, but those aren't like terms with negative 2x. So we'll just need to keep that, and then 6 plus 5 is 11. In this next example, example 9, we do need to use the distributive property. So x times 2x is 2x squared. X times 5 is 5x. We'll need to add 2 and also add x right here. 2x squared is not like any of these other 3, but 5x and x are alike. If it helps you, you can put a 1 here by the x to help remind you that just an x is also 1x. We'll add those together then. We'll keep the 2x squared on the left-hand side, 5x and 1x, that's 6x. And then we'll add 2 on the end. None of these terms are like each other, so we're finished. This one has a little bit of some distribution going on. So we'll do the 2w times the 4w and then times the negative 3. So that's 2 times 4, which is 8. And then w times w, which is w squared. 2w times negative 3 is negative 6w. Then we're going to distribute this negative 6w all the way across. So a negative times a negative is a positive. We'll have 12w. Negative times a positive is a negative. 6w times w is 6w squared. We can combine this negative 6w squared and this 8w squared. So that's 2w squared. And then also this negative 6w and this 12w. And that's going to be 6w. Using the distributive property number 11, we'll have negative 2x, and then negative 2 times positive 4, is negative 8. We can combine the 8 and the negative 8, so a positive 8 and a negative 8, that's 0. And we're just left with negative 2x. 7 plus 3s minus 2, identifying the like terms, 7 and negative 2, we can put them together, and we get positive 5. Positive 7 minus 2 is positive 5. The 3s can come first, and it can just stay. Now we get to our last couple examples here. We've got negative 6t, which is like 8t, so negative 6 plus 8 is 2t. I write my t's kind of like they're pretty fancy, they're italicized, so I don't confuse them with plus signs. And then this 4f and that negative 3f, we put those together, we get just 1f. And as your final solution here for your expression, just don't write the 1 here, you can just write the f. Last one, number 14, we've got 2x minus 3x, which is negative x. 4 and 8 is 12, and we still have that negative 7x there. If you wanted to do this all in one step, you could. This negative 7x minus x is negative 8x, and then plus 12. We need to have the 12 on the side.